at the end of class, put a magnitude, I mentioned magnitude A dot B cross C last time. But that magnitude sign is not necessary because you will get a scalar when you multiply or have a dot product in A and B cross C, which is a vector. Jake asked me at the end of class. The reason why it's sort of specified is because we have something called a vector cross product, which is some, vector triple product, which is A cross B cross C. Good. But I don't think we are going to do A cross B cross C in this chapter. Well, we will see. So we have two vectors, and we would like to find these. So there are two vectors, A, B. We want to find the cross product, the angle between A and B, area of the parallelogram formed by A and B, volume of the parallelepiped formed by A and B. We can add a couple more as we go along at the very end. Good. Okay, so we have two vectors and we want to find A cross B. First, we need to write IJK in order to find the vector A cross B, because we need a vector when we have the cross product. All we have to do, write the A vector, B vector in order. So 1, -3, 1, 1, 1, 2. To my knowledge, we typically don't go past 3 dimensions because this world that we live in is realizable only up to 3 dimensions. But the math can be extended. Maybe someday, years from today, we might enter another dimension. Who knows? I don't think so. But never say never. So what we need is the determinant of that matrix. I'm using vertical lines because the book uses vertical lines. But if you Google, you might see parentheses or square brackets. they also correspond to matrix notation. How do we find the determinant? First, we start with I vector. Find the determinant of the submatrix. I vector would mean I am blocking of first row, first column. The signs are plus, minus, and plus. We want to find the determinant of that matrix. That's easy. A, B, C, D, we simply have to do AD minus BC. So -3 times 2 minus 1 times 1. Next, we move on to J vector. Second column, first row, A, B, C, D will be the submatrix, negative. So negative J vector times 1 times 2 minus 1 times 1. Lastly, K vector. The submatrix is right here, A, B, C, D, AD minus BC. 1 times 1 minus 1 times -3. Good. So, I vector, -6, -1, minus J vector, 2 minus 1, plus K vector, 1 minus times -3 plus 3. -7I vector minus J vector plus 4 K vector. Good.
So you got this. You're a giant crab, so
Yes.
You could probably just make more money on root canals.
Come on,
He's
You
a
could
giant
probably just make more money on root canals.
through
cancer.
capitalism.
Okay, fine.
Are we clear on how we do it? Okay. Yes.
I do it in a slightly different way that gets the same answer, is that fine? Or-
What is your way?
I
Switch
just,
to the matrix.
I just don't.
Sure, yeah, you can do it that way, it doesn't matter. Couple of ways to do this. Again, I'm not going to get into the matrix aspects of things. You'll end up getting the same answer. How do we find the angle between A and B? Before we answer that question, is that angle 90 degrees? We want to find the answer to B. Is that 90 degrees then?
Yes,
Why, Chris?
because the cross product should give us a vector that's orthogonal to both A and B. So if it's orthogonal, the angle between. No,
Okay,
no, I caught myself.
okay, good. Common mistake. You find a vector using a cross product, and let's say you are trying to find the angle. Immediately your mind is going to say, oh, I found an orthogonal vector, it's going to be 90 degrees. Incorrect. The angle between A and B is something else. The angle between the vector you found and A is 90 degrees. The angle between the vector you found and B is 90 degrees. So the vector that you found using the cross product is orthogonal to A and B, perpendicular. So the angle between A and B is not 90 degrees. Now, could it be? Sure. Could it? Yes. Is that what you were about to?
I was saying, I'm pretty sure this one is 8 0 in this case.
So could it? Sure, but not necessarily. Good. In this problem, is A dot B 0? Yes. So in this case, it ends up being 90 degrees. The point is, once I've seen students compute this and immediately jump to the conclusion, the angle has to be 90 degrees, because they don't think that the angle that we're trying to find is not between A and the vector you found, rather it's between the two vectors. In this problem, it will be 90. A cross B is a vector that is orthogonal to both A and B. Oftentimes, we use the letter N. What do we use in physics? N is commonly used because I have a name. It's called a normal vector. They will use this in the next section, so we'll just write it right now so we have a good idea when we get to it. A normal vector is perpendicular to the other two vectors. The angle between A and B, if we want to use the cross product, can I erase this? Negative 7i vector minus j vector plus 4k vector. How do we find the angle using cross product? We'll start there.
Can you set the cross product equal to A cross B sine theta?
Cross product equals A cross B sine theta.
No, what is that? The magnitude of the cross product
Okay, it's equal to
A cross B sine.
Is it magnitude A times magnitude B?
magnitude of A times the magnitude of B and
Sine theta.
sine B. So A cross B equals to magnitude of A, magnitude of B multiplied times sine theta. Theta is simply the angle between A and B. The magnitude sign is important because if you don't put the magnitude sign, you have a vector. You don't know it. So let's give it a try because you know how to find the magnitude. We know the answer, but give it a try, good practice. This problem should give you an answer of 90 degrees. They are. So right hand side, it's not just a vector, rather it is magnitude of the vector negative 7i vector minus j plus 4k. Magnitude of A, we know how to find that, magnitude of B. I'm writing this so that you don't make a mistake. So magnitude of A simply means you take each component square, 1 squared plus minus 3 squared plus 1 squared, square root of 11. Magnitude of B, 1 squared plus 1 squared plus 2 squared, square root of 6. Next, magnitude of A cross B, negative 7 squared plus negative 1 squared plus 4 squared, square root of 66. You can stop and check your answer as you go along. When you divide stuff, you cannot have a number that is bigger than 1 on the left-hand side, because that is going to go outside the range of sine the unit circle, which means you made a mistake. So root 11 times root 6 sine theta. On this side, root 66. You can convert those to decimals, but each time you round or truncate, you're going to introduce a bit of error. So your answer is going to go away from 90 degrees. So keep it as is and put it in the calculator. Square root of 66 divided by square root of 11 times square root of 6. 1. Now, if you had a different number other than, say, 1, say 0.22, how would you find it using the calculator?
Inverse sine.
Inverse sine. So theta would simply be sine inverse of 1, which is pi over 2. At 90 degrees. This case, they are orthogonal, but that's not the case always. Don't make that mistake. The vector m is orthogonal to both A and B. Area of the parallelogram formed by A and B do we have to find, or do we already know?
Yeah, I think we already know.
We already know. What is that answer?
Square root 66.
Square root of 66. Because the area of the parallelogram formed by A and B is simply the length of the orthogonal vector, that is the vector that is orthogonal to both A and B, in other words, magnitude of n. We know that to be square root of 66. Before we move on, there is another way to find the angle theta. What is another way?
Inverse, no,
I
inverse.
did it this way, but there is another way.
Inverse cosines.
Inverse cosine, great, but in order to use that cosine, we need to make a change. To the left-hand side, I'll give you a hint. A dot B. So recall, you can't use the dot product to find the angle. So A dot B is magnitude of A times magnitude of B times cosine theta. It is a matter of choice as to whether you would use the dot product or cross product. I did it this way because we are talking about cross products. Part D, volume of the parallelogram formed by A and B. We need a third vector because without that third vector, you will not have volume. 2 vectors can only form area. We need a third one. So how do we find that volume?
Scalar triple product.
Scalar triple product, check. Okay. So can I erase? So the volume is simply I'm putting this just so we know that it is a magnitude. But when you find the dot product, it is going to be a scalar. C dot A cross B. Give it a try, more practice. Good question. So could I write it as C dot product between C and N? I'm doing the two vertical lines to indicate that you're finding magnitude, but it's not necessary because the answer will be a scalar regardless. C is that vector 1, 0, 2. A cross B is that one, -7, -1, full. 1 times -7. 0 times -1 plus 2 times 4. We get it. Good. So if you visualize the volume, we have a vector which is 1 unit this way, 1 unit that way, and it's going down. Yes. And the other one, 1, 1, 2, so both x and y up, so 1 down, 1 up, and you find a vector and draw it, you will see that you've come to 1. Okay. It will get squished. You may say, well, the volume looks pretty small. I'm questioning myself whether the answer is correct or not, but I'm going to say you get squished really well when you sketch. Why? The hint is in there. We have a small volume, which means that I don't have a huge parallelepiped, so kind of skinny. Well, one, 0, 2. Right? That would mean it is a plane, but we don't have one axis. Yes, so we simply have x and z. We are putting it against a plane, so it has to be really close and squished. And this is why we get a small volume. So with more practice, you'll be able to visualize. Good. Okay. Here's another example. So we want to find 2 unit vectors that are orthogonal to the vectors 1, 2, 5, 1, 4, -3. We know how to find the vector that is orthogonal to these 2. Agreed? How do we find it? Cross product. So if I find a vector A cross B, this will be orthogonal to both A as well as B. Let's find the cross product. Give it a try, good practice. Okay, so we would define this vector, which is orthogonal to those two. I'm going to just have it, write it and make its form. Yet another reason as to why the book simply goes for this, because they are denoting a determinant directly. When I write this, I would do that. That's what I meant by parentheses. But then you'd have to use another line to represent the determinant. The book simply goes for the determinant right away. But some books would simply write that as a matrix, but that's not right. Because you have to put two lines or write the determinant as det or A. Okay. Same process. Plus, minus, plus, I vector, those two, minus 6, 2 times minus 3, minus 6. New with parentheses. Always minus 5 times 4, negative 20. The second column, when you get to J vector, it has to be negative. So that column gets blocked off. So it's the first row, pick the negative. So negative 3 times 1, negative 3. 1 times 5, so we've got to subtract, negative 5. Lastly, K vector. That column gets blocked off. So you have 1 times 4, minus 1 times 2. Or minus 2. Good. Negative 26 I vector. Negative I times negative HA vector. 4 minus 2, 2 plus 2K vector. Good. What is the difference between a vector and a unit vector?
Unit vector is magnitude 1.
Unit vector has a magnitude 1. We know n vector is orthogonal to that. If you find the unit vector corresponding to, say, some vector A, do you believe that the unit vector will point in the same direction as the vector A? Do you follow my question?
Say it again.
If you have a vector A and you find its unit vector, do you believe that the unit vector for A will point in the same direction as A?
Yes.
Yes, it is going to point in the same direction, but the magnitude is just 1. Same direction, mean angle. So whatever angle that n has will still be preserved if you convert it to a unit vector, because the angle doesn't change, the magnitude changes. So the unit vector is found by dividing that by its magnitude. Square root of negative 26 squared plus 8 squared plus 2 squared.
It's
676, 64, 2. Yes.
The last one's 4, plus 4.
What?
Like
Plus
6.
four.
Oh, thank you, bad math. I had to go back to
Oh, yeah.
or elementary school. 746, 744. If we want to find U vector, the unit vector, I'll call it n sub u. It is simply the vector n divided by its magnitude. So 1 over square root of 744 multiplied by negative 26i vector plus aj vector plus 2k vector. You may ask, well, why do we even bother finding unit vectors? Unit vectors are easy to manipulate and, in all kinds of ways. When compared to the actual vector. One might ask, well, are you going to lose information? You're not going to, because they're pointing in the same direction. So you're not losing information. All you're doing is adjusting it so that the magnitude is 1. Great. Problem says find 2 unit vectors orthogonal to those 2 vectors. We found 1. How do we find the other?
Multiplied by -1.
Multiplied by -1. Why?
Because that'll flip the directions of I, J, and K.
So if you have one vector that is orthogonal, the opposite side will also be orthogonal, right? So all we are doing is multiplying by -1. Hey, look over there. Actually did this. So the second unit vector, I'll call it E. Simply negative of the first one. So -1 over square root of 744. That bit is easy, but why? If someone asks, well, why is it true? Well, if you have 2 vectors, let's simply take our usual case. I have those 2, and I simply ask, well, find a unit vector that's orthogonal to these 2. Well, it's right over here. It's opposite of that. So you simply have to multiply by -1. Another explanation would be, well, I have A cross B. Yes, but I can also, I'm going with A cross B because I wrote that first and I wrote this next, correct? I can move this over here, move that over here. If I'm going to look in reverse, agreed? So instead of doing A cross B, I could have done B cross A. If you did B cross A, you will get the vector E. How do we do it? Well, I vector, J vector, K vector. All I'm doing is switching the 2 vectors, which would mean I'm going to swap the rows. So 1, 4, minus 3, 1, 2, 5. Good. The determinant. If you did the computation, you will end up getting 26i vector minus 8j vector minus 2k vector. Good. again, I don't want to simply write this and say, good day, we want to know why. I'll just pick a simple case because this is not a class in linear algebra. Can I erase this part?
Did you just happen to know that 26 squared was 674, or did you
676.
676?
Yes.
Yeah, okay, just out of curiosity.
No, I lost my train of thought. We know that, right? Simple identity matrix. One next to zero matrix. What is the determinant of an identity matrix?
1, 2, 0.
Zero. So you are saying if I took the usual unit vectors in 3 dimensions, the determinant would correspond to a scalar triple product in a sense, because we're dealing with unit vectors. So the volume of the parallelepiped would be 0. The area of the parallelogram will be 0. Easy question, 2 unit vectors, find their area. Well, let's not even go there. Could area be 0? No way, right? So determinant cannot be 0. Yes. So if you get an answer of 0 for determinant, you are making a mistake. Can't be 0. In this class. In linear algebra, if the determinant becomes 0, then the matrix is not invertible. In this class, in this section, you cannot get 0. Good. Let me add that note. This is one. Good. If you have unit vectors, you form a cube. What is the volume of that cube? 1 times 1 times 1. Great. There are 3 rows, do we agree? I want you to swap. Give me 2 rows.
2 what?
Rows. So I have row 1, row 2, row 3. Pick 2 of them.
1 and 3.
1 and 3. Okay. Can't pick 1 and 3. I'm going to simply swap. Good. Switch. I will write it as 0, 0, 1. 0, 1, 0. 1, 0, 0. Yes. What is the determinant? Want to give it a try? If you go through the process of determinants, you will get -1. In this case, the determinant is -1. Going back a couple of lectures, we have a volume, and that volume ends up being negative. But volume cannot be negative. We encountered a scenario like this before, and Chase actually gave me the answer to that scenario as to why it was negative.
So direction,
Direction of what?
where it is on the, in the octave.
Close. Getting close to me. You forgot?
What the answer I gave you today?
No, a couple of lectures ago, when we did areas of parallelogram, we found the area once it was positive, the next found it was negative. And I said, well, area can't be negative. And hold on, so Jeff over there said direction. Almost correct, but 99% correct. There's one other part. Direction of blank. Word game. Starts with S, ends with H. 4 letters missing.
Terrible word games. Scalar.
No,
It's-
it's five letters.
It's
No,
fine.
5 letters. My bad.
5 letters in total or 5 letters?
5 letters missing.
Oh.
It's stretch.
Stretch, right? So in the area scenario, when we stretched, if it went this way, positive, that way, negative. That's how I started determinants last week. Same thing, parallelepiped, if you went this way, still the same parallelepiped, you just stretched it. Move it in a different direction, negative. So determinant can't be negative, it simply indicates that you're stretching in a different direction. That's what Jeff was referring to. So what has happened, anytime you swap 2 rows in a matrix, its determinant will change in sign. With every swap, it will change sign. If I revert it back, swap rows 1 and 3 again, that negative determinant will become positive, in other words, 1. So each time you swap rows, the determinant of the matrix will get multiplied by -1. Good? That's the matrix explanation. So I gave you a geometric explanation, matrix explanation. What did we do when we did B plus A? We simply swapped A and B. Yes? So if one of them is that letter, naturally the other is the negative for that. Does that make sense? Say. Are we clear?